First, we're going to take a look at 3 to the negative fourth power. So remember what I said about negative exponents. If we have 3 to the negative fourth power, all we need to do, if we want to make that negative exponent into a positive exponent, is to take 3 to the negative fourth power and put it in a fraction under 1. Once we do that, we can make this negative sign positive. So 3 to the negative fourth power is 1 over 3 to the positive fourth power. Think about it, right? With scientific notation, negative exponents mean we have a really, really small number. So if we have 3 to the negative fourth power, that's a negative exponent. We should expect to get a small number. That's why we put it in a fraction. 1 over whatever 3 to the fourth power is will give us a very, very small fraction. Noah? There's a couple people waiting to go, so just be patient. Jordan, don't need that. Number 2. Anything to the 0th power is equal to one number and one number only. What's that number? 1. Even 35 to the 0th power, that's equal to 1. Four to the 4th power, I think it's really asking us to find the value here. So 4 to the 4th, that's 4 times 4 times 4 times 4. If we take 2 of those 4s, we get 16. And the other 2 4s, we get 16. And that's right, 16 times 16 gives us 256. We know that from our perfect square unit, right? 256. We could even simplify number 1 if we want to. 3 times 3 times 3 times 3 is just 9 times 9, which is 81. So number 1 we could say is 1 over 81, or 1 over 3 to the 4th power. Any questions on 1, 2, and 3? Basic understanding of negative, positive, and 0 exponents. Any questions on that? Good. Let's take a look at some properties now, or our exponent rules, if you remember. Why did this happen? There we go. So first one is product rule. Product rule. When we have like bases, which means the same large number with a different small number or exponent up on the top, whenever we multiply like bases, we just add the exponents together. So we get 8 to the 3 plus 7, which is 8 to the 10th power. Number 5, that's the quotient rule. And the quotient rule says if we're dividing like bases, we've got a 12 to the 6th power over 12 to the 2nd power. When we're dividing like bases, we just subtract those exponents down. So we get 12 to the 6 minus 2, which is 12 to the 4th power, just like that. So when you see multiplication, think addition. When you see division, think subtraction. And this third one here, number 6, that's the power rule, which states if we have an exponent being raised to the power of another exponent, what do we do with those two numbers? We multiply them. 10 to the 3 times 5 gives us 10 to the 15th. So notice how we had 3 different setups. We got 3 different answers, and we did 3 completely different things. But these 3 steps all look very similar. right? We've got that same like base. We've got the two numbers, the two exponents up top, but we're doing something different each time. In number 4, we added. Number 5, we subtracted. In number 6, we multiplied. That looks weird with my fingers like that. Anyway, looks like I had like 3 hands. Anyway, questions on exponents. That's pretty much it. It's pretty self-explanatory. We've had a lot of practice with this. It's just been a while, so if you do have questions as they arise, please let me know. Let's move on to scientific notation. Did you guys learn or use scientific notation in your science class this year at all?
No.
Some of you saying no, some of you saying yeah.
Yeah, we did.
Maybe we got different teachers. You're definitely going to need it next year in science, so let's make sure we know before we get out of here what's going on with scientific notation. So, 2,000. Is that more than 1 or is that less than 1? More than 1. So is my power of 10 here going to be positive or negative?
Positive.
We're going to have a positive power of 10. I'm going to keep that in mind. Oh, well, obviously this section is just positive, but still, it helps for us to point that out. 2,000. Where's my decimal point right now?
It's at the end.
At the very end, behind 0. Is that right, Noah? That's right. Where do we want that decimal to end up? At the very front?
Between the 0 and 2.
Between this 2 and this 0. That's where we want it to end up. So remember, we draw a dot where it's at. We make a little arrow to where we want it to be. And then we count how many spaces are in between. 1, 2, 3 spaces gives us 10 to the 3rd power. So what number is going to go in front?
2.2.
What now?
0.
2.0 times 10 to the 3rd power. So remember, we move that decimal until there's only one number to the left of our decimal. And then we take that number and put it in front. 2.0. Where's my decimal in number 8, though? Is number 8, is that bigger than 10 or smaller? Or sorry, bigger than 1 or smaller than 1? Bigger than 1. We're going to have a positive power of 10. Something times 10 to the something. Where's my decimal point in this number right now?
After the 0.
After the 0. Which 0?
The 0 at the end.
So right here's where my decimal's at? Good. There's my decimal. Where do we want it to end up? In between which two numbers?
9, 1.
In between the 9 and the 1. Exactly. Right there. So we need to move it 1, 2, 3, 4, 5, 6, 7 spaces. 10 to the 7th power. Now, what number is going to go in front? This one's a little bit trickier. 9 point, what? 9.1?
9.175.
9.175. We're getting closer. How about 9.10075? Times 10 to the 7th power. We can't get rid of those 2 zeros in the middle, but we also can't leave off the 7 and the 5. That's important information that we need to know. Right? Think about it if this was money. Let's say you were getting $91,007,500. Well, if they forgot about the 7,005, well, if you're getting 91 million, I guess it doesn't matter about 7,000. But if you want all your money and they cut off that 7.5, you're going to say, hey, I'm missing $7,500. So whenever we have numbers that aren't 0, we have to include them in our answer. They contain important information. If there's zeros in between our numbers, like we have here, 10075, we have to include those zeros as well. Are there any questions about that? Let's take a look at number 9. We're going to reverse it now, going from from scientific notation to standard. How many spaces am I going to have to move this decimal here? How many spaces do I move it? 10 spaces?
9.
9 spaces. Where'd you get 9 from, Jordan?
From the times 10 to the 9th power.
That's right. The exponent on our power of 10 tells us how many spaces we have to move the decimal. So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 3, 9, 5, 0, 0, 0, 0, 0. So we end up with what? There's a comma there, comma there, comma there. 1,039,500,000.
That's a big number.
That is a big number. Let's take a look at number 10. Where's my decimal here? All I see is the number 4. I don't see a decimal. Where's my decimal at? Is it to the left of my 4 or to the right of my 4? To the right. So if we're multiplying it times 10 to the second power, how many spaces do we move that decimal? 2. Ooh, my voice cracked. My bad. 1, 2 spaces, just like that. My decimal is now at the end of my number. We got to fill in all those empty spaces with zeros, and we get 400. Right? Let's think about this a different way. What's 10 squared? What's 10 squared, everybody? 100. Now what's 4 times 100? 400. We got the same exact answer, either simplifying it out or by doing the scientific notation way of doing it. All right, those are all positives. Now let's look at some negative scientific notation. Number 11, 0.02. Remember, we want one number to the left of our decimal. So how many spaces am I going to have to move this decimal until we have one number to the left? 2 spaces. 1, 2. We get 2.0 times 10 to the negative 2 this time. Because our number is less than 1, we've got a negative power of 10. I think Noah was next, and then you can go. Or no, Jira, and then Noah, and then you can go.
I already went.
You already went? Perfect. Noah, then you can go. Sure, if I can remember that one. Number 12, how many spaces are we going to move this one? 5 is super close. Looks like 4, right? 4 spaces. We want 7 to be the only number to the left. We get 7.01. What's my power of 10 here going to be? Negative 4. Good. 8.9 times 10 to the negative 5th. We're going to move this decimal 1, 2, 3, 4, 5 spaces. 0.1234 zeros, 8, 9. Two spaces to the left over here gives us 0.0441. Zero point zero zero. Sorry, 0.0441. Cross off the rest. Don't worry about all that nonsense. We're going to stop there at 14.